Alright, so the question is, why do we solve? We solve for two particular solutions, or reasons I should say. Why do we solve quadratic equations, in other words? One, to find the x-intercepts, and two, to find the crossing points of two expressions or when they're equal. Here we have an example. Negative x squared plus 1 equals negative 5x. And I've taken the liberty ahead of time, as you've noticed, to graph this. That way it makes it a little bit easier for you to visualize. Keep in mind, if you're doing it by hand, you're plotting points, right? So your graph may look somewhat similar to what mine did, which mine looks sort of like that. So if we graph them separately, that would be my top two graphs there. The top left with red dots and top right with blue dots. So notice my equation, y equals negative 5x. That was originally the right side of my equation from the example. And my blue one on the top right, negative x squared plus 1, that was originally the left side. So top left, linear equation, top right, parabola. So if we overlay them, that's my bottom left graph there. Overlaying them, basically we're seeing where two graphs intersect each other. So that's just having two separate equations. You're finding where they intersect each other. So intersection points is what we call them. They intersect here and here. I drew arrows there so you can visually see where they intersect. So we can see it intersects at 0, x is 0, and x equals roughly, I would approximate that to be 5, x value. Keep in mind, we're just seeing the x value for these cases. Now, on the other hand, if you set it equal to 0, meaning move everything to one side, like in this case, on the right, bottom right, I have it equal to 0, meaning I got rid of everything to one side. So it became negative x squared plus 5x plus 1, and it equals 0. Then you're looking for when does it cross your x-axis. In other words, we call them your intersections, or your, pardon me, not intersections, intercepts. It's your x-intercepts to be more accurate. And there it is. I drew a couple of arrows there, that way you can see where your x-intercepts are. And they give you the exact same x values at x equals 0 and x equals 5. So therefore our answers are x is 0 and x is 5. So once again, why do we solve? Well, it depends on what you were given or what you start with. You have two separate equations and you graph them one on top of each other. You're finding where they cross each other. Or you have one expression, one equation, and set equal to 0, meaning pass everything to one side. You're solving for the intercepts then. Does this give you a better visual? Let me know.